Hello and welcome to my presentation on InfoDrainage, Optimizing Drainage Design Workflows. Thank you for taking the time to join the presentation. My name is Matthew Piggott and I am a water resources engineer for Innovise, part of the Autodesk team in APAC. Today's presentation is going to be a combination of slides and a demonstration of the integration workflows between InfoDrainage and Civil 3D. I will be covering common challenges based in everyday drainage design, what the integration model looks like for transferring data between Civil 3D and InfoDrainage, as well as describing the round-tripping workflows. Then I'll do a demonstration of this integration workflow, plus we'll look at key features that allow InfoDrainage to optimize and streamline design workflows. Lastly, I'll review some complex drainage infrastructures and how they are handled through this round tripping process. And I guess we won't have time to do a Q&A today as this is recording, but I'm happy to take any questions offline. To start, let's look at some specific drainage design challenges that InfoDrainage aims to solve. Planning permission or consent for any land development is dependent on a sound strategy, and drainage design is typically the last to design based on civils, while also being one of the first to excavate for construction. Increasing constraints and project costs mean it's important to get things right the first time round, but that doesn't always happen. Delays to any approval can affect construction and can impact consultant engineers' margins as well as their customers. Many of the drainage design challenges we hear are linked to the exchange of data with other packages. So with our InfoDrainage product, we have built an integration with Civil 3D that installs as a ribbon to allow data to be exchanged via parts mapping. Ensuring you can accurately represent and analyze both traditional and your sustainable drainage is fundamental to InfoDrainage. We've seen plenty of design packages that support part of the drainage design or rely on complex modeling techniques to try and represent green infrastructure elements. This can result in a graphical representation that doesn't match the design and lots of rework in CAD packages each time the overall site design is updated. InfoDrainage offers accurate graphical but also hydraulic representation. Ensuring how the water passes through the green infrastructure is central to the hydraulic engine, as well as giving consideration for the effects of the structures slowing down flows. Graphical feedback from these results, such as a pipe capacity being exceeded or flood risk level warnings, can be shown both in the long section as well as in the plan view directly, helping to inform user and various stakeholders that specific areas of the design may need further optimization for some storm durations. InfoDrainage as a standalone package can be used by engineers, coordinators, admins, or even decision makers. It has capabilities to achieve environmental protection and community resilience through design, enable designers to meet regulations, improve productivity, can reduce errors and rework, and eventually save time and costs. Reasons why the industry is adopting InfoDrainage today is due to its easy to use next generation interface. It has a rigorous detailed hydraulic analysis engine built in. It can take you from conceptual through to detailed and issued for construction in the one package. It has validation and visualization tools, allows better integration, and is aimed to be a global product by being able to adapt to many of the local markets. Now, focusing in on the challenges that relate to the area of BIM compliance. Why is this important? As we've noted from the overall challenges, the drainage design rarely happens in isolation. We need to use data from a range of sources, but we don't want to duplicate effort to do that. Designs need to be taken from concept through to as-built construction and will often involve iterative changes throughout the project. This can be a painful and time-consuming process. With the data exchange in Civil 3D, that includes a representation of all aspects of the drainage design, we can optimize the design workflow so that engineers can efficiently represent their design, giving greater confidence in the validity and accuracy of design information. InfoDrainage is a standalone drainage design package that can be used without Civil 3D. But with InfoDrainage for Civil 3D, we can make maximum use of the existing work already done in Civil 3D and ensure our overall site design remains up to date. InfoDrainage for Civil 3D, or InfoDrainage Ultimate, installs as a ribbon within Civil 3D and is designed to allow the exchange of data between Civil 3D and InfoDrainage via a parts mapping manager. I might mention here that more Innovyze products are beginning to see integration with Autodesk products. Very soon, modelers will be able to commute information between InfoWorks ICM and Civil 3D. Please feel free to contact me later for more information about this. Users can follow two workflows when using InfoDrainage for Civil 3D, either starting in Civil 3D or starting in InfoDrainage. Working with customers, we find the optimal workflow usually originates and finishes in Civil 3D, enabling users to use the best of both packages and avoid duplication of effort creating an initial layout. The central part of the workflow undertaking in InfoDrainage may include comparing different sustainable drainage or green infrastructure options through its scenario management tools. Finally, we bring the completed design back into Civil 3D where the rest of the site design lives. It is expected that iterations will occur and we may need to go around the loop multiple times. So now I'll begin to show the InfoDrainage Civil 3D workflow integration. As we walk through the steps needed, focus on the aspects that relate to using InfoDrainage for Civil 3D rather than setting up these pipe networks in either package. I'm going to start out with a simple concept network laid out in Civil 3D using one particular pipe size and manhole type. So here I have my Civil 3D model with some various information included already, such as a surface model. I have XREF in a proposed development, and I have my pipe network laid out shown here. At this stage, it's a concept and it will need to be sized up. We can see one of the main trunk alignments through this profile view down below here. And using Project Explorer, which is part of the AEC collection, I can have a look more closely at the information along this pipeline. So Civil 3D can help you add some rules when you're laying out the concept design. And if I come to the pipes here, we'll see that all of these pipes are actually a 225 mil diameter concrete pipe. So now I'm going to take this design into InfoDrainage to size up according to specific rainfall events. To first export the design, we come to the InfoDrainage tab, and then we select Export to InfoDrainage. We then select the InfoDrainage file we're saving the data to. If we have multiple pipe networks within Civil 3D, we can select which ones we want to design. And we even have the information to bring in extra information like the surface model. Here we use the parts mapping manager to map the Civil 3D part sizes to the correct sizes in InfoDrainage. It's not critical to get it correct this first time around, as we're going to be sizing up the network anyway. We'll see when we bring the design back how it's important to map the info drainage size to the correct 3D part. So now I'll just open up the created model. And now we'll have our information brought over into InfoDrainage, ready to go through the drainage design workflows. So I guess before we do go through the workflows, I'll give a brief orientation of InfoDrainage for those who are not familiar with it. It's kind of similar to I guess some Autodesk products where we have our ribbon menu up the top here with the various actions that can be completed under each menu item. In InfoDrainage, the menu has been designed to step you through typical drainage design workflows, from importing any of information from various sources, generating your rainfall, using the preliminary or initial sizing tools. InfoDrainage has many calculators to streamline this part of the workflow, to building out any extra elements of the design, conducting a full dynamic analysis, to checking through the results, generating various reports, and then exporting out that information for approval. The first thing we'll have a look at is I'll generate some long sections just to highlight the information that's been brought in. So if we remember from our Civil 3D profile, we have that information now in InfoDrainage. We have the 225 diameter pipes and the same network layout. So one of the first steps to, I guess, starting out initial drainage design is loading any background data that you might have. So we can bring in any surface models, reference CAD drawings, reference GIS data, or even aerial images if we have them available. First, I'm going to bring in the same referenced CAD file for our proposed development. So we can see that we're still working in the correct location. Next, what I'll do is, if we're working in any locations around the world, we can set up some regionalization. This will either hide or present the specific tools that are necessary for drainage design in that specific location, as these tend to change depending on which region you're working in. Then I'll load the object templates. Essentially, this is a standard template or library specific to your particular project, or even for the authority that you're doing the design for. This example that I have here is a library designed for the PUB in Singapore. So with that, we're going to have already populated information about our catchment hydrology and its setup for each different land use. Additionally, we might have standard junctions or manholes or sumps that we design for. We might have standard rain gardens, swales, or even culverts or pipes that we typically use for that particular authority. Okay, so just before we get into stepping through the design, I'd like to highlight the types of things that InfoDrainage can help model, from your traditional drainage, from your pipes and tanks to your green infrastructure. As you can see here, you can model elements such as bioretention layers, cellular storage, underground chambers, model dry wells or soak wells, infiltration trenches, ponds, porous pavings, rain gardens, swales, and tanks. InfoDrainage also includes various calculators to streamline the design of this infrastructure. I won't go through it today. So from here, what we're going to do is add our catchments. And we're actually going to import our inflows or catchments from a GIS layer. I might mention here as well that we can use Civil 3D and its watershed development tools to generate these catchments for us. Now, as you can see, I'm able to select the required hydrology and parameters because I've uploaded in that object template earlier. So then I don't have to go through each catchment and set up the information. Now we have my catchments. The next step that I'll do is bring in our rainfall. So InfoDrainage incorporates many tools to automatically create design storms, whether you're working in the US, UK, Australia, or China or France. There are some design tools there for you. Otherwise, we can use the Rainfall Manager tool to build out our rainfall. This specific example is showing that we can load in the Singapore Island IFD table. I'll press OK to accept. Now, working through the menus, we're going to come to preliminary sizing. First step is to set up our network design criteria. We select our rainfall, the return period that we're designing our infrastructure for. So in this case, it's the 1 in 10 year rainfall event. And then we can set up our design options. If you have pipe libraries, these can be loaded in. This is going to make sure that we're designing to a specified minimum pipe diameter, and then it will let me know each available pipe size to choose if the capacity is breached for a lower pipe. We can set minimum cover depths, a range of minimum and maximum slopes for the design, whether we have drops in our sumps or pits. And we can tell the engine to make sure we're checking velocities as well. There's also options for entering in a sump or pit library as well, but I won't get into that for this demonstration. Then we come to the design wizard, and we can select the entire network to design or individual long section flow paths. We step through the wizard, checking our criteria that we've set up. And lastly, we'll come to a table where the changes are highlighted to us. If there's conflicting criteria for some sections, warnings will be generated for us. So we can check both the pipe and manhole changes. So what I've demonstrated here is for a typical pit and pipe network. But if we're designing culverts and open channels, the sizing wizard can also be used to size up these based on a set criteria. So we press finish to accept the changes, and then we'll be taken to the design report where we can view the hydraulic results, such as the flow. We can even filter through some detailed reports to get a bit more information. Then we can check out our flow profiles and see how the sizing wizard has sized up our network. It looks like we have a little mistake in our network here. So we need to go back and fix that up. Other ways that we can view mistakes and warnings in the network is through the validation tool. So the validation tool can be run for the network, and any errors or warnings will be shown to us, giving some detailed information on what we need to fix. So it looks like we have some catchments that aren't connected to the network, as well as the mistake with the manhole in the long section. So what we'll do now is fix up those elements. Making sure that we do have a manhole in the correct location. Then we can reconnect the catchments to those manholes and then run through our design again. So now, if we run the analysis, we should have everything okay. Running back through the wizard, we'll see what changes come and press OK to finish. We'll check that long section profile again, and we'll see it's been designed more appropriately now that that fix has been made. We can also have a look at individual flow paths and step these through the design wizard as well, just to focus the design criteria on that particular portion of the network. So it looks like we've got some invert changes. So if I finish that and come back to the long section profile, we'll see that the design more closely follows the ground level now, which is going to make it more efficient for construction. The next step is to actually run the hydraulic engine so that we can optimize the design. It'll check the whole network as a whole, so we can account for things like volume, or if we have tricky design situations that are typical in urban areas where we might have backwater effects or reverse flows, this will actually be picked up by the detailed hydraulic analysis engine. First step would be to run through some analysis criteria. Can select the storms that we wish to analyze. This one here, I'm running actually 120 different design events to optimize my drainage design. And then we can run the simulation. So InfoDrainage allows parallel processing. So if you have the resources, such as multiple cores on your machine, you can split the simulations up across those so that you can quickly run through the simulations at a faster pace. So once the analysis engine is complete, we will be given a result summary table where we can check the status of the network. So this is looking at this particular rainfall event, where it looks like the flow is contained within our network with some pipes being surcharged. If the water level isn't actually surcharging out of the pipes, then that'll be okay for design. We can also toggle through the storms and select the critical one or the worst case. So as we can see here for the 1 in 100 year extreme rainfall event in the 10-minute duration, we're actually getting some flooding surcharging to the surface. So we can view that event individually, both in plan and long section. Through the theming, we can see the pipes that are highlighted are the ones that are surcharging, and then we can step through or play through the actual simulation event. Theming on the screen will show us as well particular pits that are surcharging. So those in red mean that flood is coming to the surface, and the orange one means that we're breaching our freeboard. So we're within 300 mils of spilling to the surface. We can actually view these in long section views as well. So if I come back to the start, we can play through that information on screen with the themes showing. There are many ways we can view results through the summary tables that we showed previously. We can generate graphs of individual drainage elements. We can also create manhole schedule reports We can look at some takeoff data, which is useful for estimation if you choose to do that within InfoDrainage. Otherwise, there are tools to do it within Civil 3D. One of the most useful reports is the audit report, where we can set up criteria based on a range of parts or situations of the drainage design that need to be ticked off. As you can see, we have some of these elements succeeding the audit report and some of them failing. So things like our pipe length, the report will highlight to us quite quickly which pipes are too long before we need to put in a maintenance hole. If we have any cover depths that are too deep for excavation, as well as our velocity checks. So all this can be checked through quite quickly, so we can go back to our design and optimize it so that it can pass an approval stage. If we also have different scenarios that we're analyzing side by side, the comparison report is going to be a useful tool. So from here, we'll assume that the design is complete and we'll save the file. Now we're going to bring the design back into Civil 3D. So we select the import from InfoDrainage via the InfoDrainage ribbon. We select our drainage design, that's complete. And then we step through the wizard. So if we have multiple scenarios, we can select them here in this part of the wizard. I'll just make sure we're using our same surface model. And then we come back to the parts mapping manager. Now we can map this out individually, but we can actually save some time by loading in a parts template. So this will populate all the fields for us to the correct Civil 3D part family. So that's for our pipes and our manholes as well. So press finish to accept the mappings, and then the new design will be updated within Civil 3D. So we can see that our profile on one of our alignments has been updated with the new changes. I will then go into Project Explorer quickly just to highlight the changes that have come through. So we can see here the new alignment has been updated, and we can check out all the new pipe sizes that are being generated from the sizing tool. So not only can our pits and pipes be imported and exported between InfoDrainage and Civil 3D, but other complex structures, such as our basins, our tanks, and our swales, can be represented as part of this round tripping as well. So the design's incorporating our suds, or WUSUDs, essentially it's this green infrastructure, can be brought back into Civil 3D via a similar guided import process. So in this example, actually bringing in a model that contains some swales and a biobasin. You'll be able to see the visual representation of the design in a couple of the native Civil 3D views, including the useful 3D orbit. So our stormwater controls are accurately represented in the surface as laid out on plan in InfoDrainage. So further design iterations within Civil 3D are minimized by maintaining correct connection. Inlet and outlet locations are in the correct locations as well. And many of the green infrastructure elements shown here are represented as feature lines with a mesh surface. These can be edited for the round tripping, both in terms of changing levels and the shape. Thank you for taking the time to listen to my presentation. If you do have any questions, please reach out to me at matthew.piggott@autodesk.com, and I'll try and answer them as quickly as I can. Thank you.